Hello my dear students, this is Felix Balaji. Today let us discuss a problem based on circular motion. In this it is given a uniform thin circular rubber band of mass m and spring constant k has an original radius r. Initially it was a circular rubber band having radius r. Now it is tossed into air. Assume it remains circular when stabilized in air and rotates at angular speed omega. Now in air this was rotating like this with an angular velocity omega. As it rotates, due to centrifugal force, it acts away from center. Due to that, the rubber band gets elongated by small change delta r. Now the final radius will be r plus delta r. So which of the following gives the new radius of the rubber band? You are asked to find what is the new radius of the rubber band. As the rubber band rotates with an angular velocity omega, it elongates and its radius increases by delta r. Now the final radius becomes r plus delta r. Consider a small elemental part of the rubber band having mass dm. As it rotates, centrifugal force acts away from center. Now I can show you centrifugal force acting on the small element will be dm. New radius will be r plus delta r into omega square. On this part of the rubber band, so it will have some tension T here also tension T. So the remaining part of the rubber band hold the small elemental part with the tension T. So this elemental part makes an angle here d theta and the half will be d theta by 2. It's a right angle triangle, you can see, because radius and tangent will be always perpendicular. So it is d theta by 2, it is 90 minus d theta by 2. So if you draw a horizontal, this becomes again d theta by 2. If you resolve t, this becomes t cos d theta by 2. So one more component here, t sin d theta by 2. Similarly, this t also resolved two components. This becomes t cos d theta by 2. One more towards center is t sin d theta by 2. Now, centripetal force balanced with centrifugal force. Centripetal 2t sin d theta by 2 balances centrifugal force dm r plus delta r omega square. So it is small angle. For small angles I can write simply sin d theta by 2 as d theta by 2. Linear density formula, total mass of rubber band by, so total length of rubber band 2 pi r equal to small elemental mass dm and its arc will be, the length of this arc is nothing but r d theta. So this becomes r d theta. So here we can make r cancel. So now dm value becomes m by 2 pi into d theta. Substitute dm value here. Now finally 2t d theta by 2 equal to dm value m by 2 pi into d theta r plus delta r omega square. Here I can keep d theta cancel, 2 cancel. Tension in the rubber band is given as k into total change in length of the rubber band. Length of the rubber band for circular path is 2 pi r. Change of length delta L equal to 2 pi into delta r. Substitute here. Now this t becomes k into 2 pi into delta r. Substitute t value there. So k is spring constant into 2 pi delta r equal to m by 2 pi into r plus delta r into omega square. Now you can bring all r terms one side. So k into 2 pi into 2 pi 4 pi square by m omega square equal to r plus delta r by delta r. We know delta r value. Delta r means change in radius, final radius minus initial radius. You are asked to find r dash value, final radius only. So k into 4 pi square by m omega square equal to r plus delta r value, r dash minus r by delta r value, r dash minus r. So you can see r gets cancelled. So make it reverse. M omega square by k into 4 pi square equal to r dash minus r by r dash. You are asked to find r dash. So m omega square by k 4 pi square, LCM separate means 1 minus r by r dash you will get. So r by r dash equal to, bring to the left, 1 minus m omega square by k 4 pi square. Now do LCM and write r dash as subject. That's your answer. So finally r by r dash equal to k into 4 pi square minus m omega square by k 4 pi square. So finally I want r dash. So r dash becomes k into 4 pi square r by k 4 pi square minus m omega square. This is our answer. Thank you.